Hey folks, okay, continuing on our work with character arrays and with strings, I wanted to get into a little bit of the conversion process now. Let's say that we've got data that's stored in a character array and we want to extract pieces of that and store it in other variables or maybe even in variables of other types. So let's say we've got a string that contains 37.5 or a character array that contains 37.5 and then an old terminator, and we actually want to get the 37.5 out of that but treat it as a float, for instance. Or the other way around, I've got a float 37.5 that I want to store into a character array as text or into a string. Right? So I want it stored as the string 37.5. We'd like some way to go back and forth between strings or between character arrays and other data types. Maybe we've got a string with a bunch of different pieces in it. So something like an address, 900 5th Street. And what I want to do is, out of that longer string, I want to just get the 900 and store that as an integer. Or I want to just get the 5th and store that in another string someplace. Or same idea, if I've got this stored in a character array with a null terminator afterwards, can I go through and grab the 900 and the 5th and the street separately? So these are things that we would like to be able to do. So we'll take a look at some different ideas for doing this. In cstdio, one of the things that we can do is to use a function called sprintf that's like printf, only it prints into a character array instead of printing to output. Or a function like scanf that scans, it reads, but it reads from a string instead of from input. So we can say things like read an integer from the string, or we can say things like write an integer into a character array rather. And then there's an sstream library that allows us to do the similar things with cin and cout. So we'll have a bit of a play with those. First, I wanted to mention a couple of functions that are purely for converting back and forth between integers and floats and strings or character arrays. So let's have a quick play with those first. So let's do some, let's say, number conversions. We'll do this with iostream first, and with strings. So let's say, oops, I don't want my string library here. And so I'm going to just quickly create an integer variable. So x, and we'll store maybe a 97 in there, and a float f that we'll store 1.234 in. And we'll have a string. And so, oops, actually, let's do it the other way around. What am I thinking? Let's have a string 1 that we'll store a 97 in. And, yeah, a string 2 that will store our 1.234 in as string, as text. Blah. We'll do the conversion the other way in our next section. So I've got these couple of strings that have data in them as text. And what I want to be able to do is to convert that text to an int or to a float. So let's say I've got some integer variable I and some floating point variable f. And I want to get that string, that first string, and convert it to an int. So I can say I is equal to, and it's stoi for string to int. And then I give it my s1. Or similarly for floats, I can say f is equal to stof for string to float, and my s2. And so I'll print out my s1, and hopefully this comes out the same, and my I. And the same sort of idea, s2 hopefully comes out the same as my f. And so in each case, I've got one of them stored as a string and the other one stored as an int, or one stored as a string and the other stored as a float. So let's try this and see what disasters befall us. Oops. Yeah, so far so good. And sure enough, it went through and converted the text 97 into the int 97, or the text 1.234 into the float 1.234. Now, one of the things that you have to be aware of is what happens if they give you garbage. So now let's say, let's put, why not? Let's actually use garbage in S1, and we'll say I is equal to stoi S1, and F is equal to stof S1. So we'll see what garbage comes out as when we try and do this conversion. So we'll just show what conversions we get from stoi and stof when we give it things that don't have valid numbers in them. Oops. And oh, so it's actually going to yell at me for not passing it valid data. Oh, that's interesting. With the A to I ones that we're going to take a look at in a moment, it will actually give us back a value of 0. Okay, well that's actually not a bad thing either. So this will go through and tell us that we've actually provided it invalid content. And then I'm assuming it's going to do the same thing with the second one. And yes, sure, oops. Guess I should recompile. And yes, oh no, I'm not getting my Oh, I see. We'll get there. And yes, same thing with the stof. Okay. So the next technique that we look at, we'll play with this a little bit more. So we can go through and come up with conversions from strings to ints and floats, although we had better do our error checking that we're actually not passing garbage apparently. And now let's try a similar sort of idea, but with text arrays. So I'm just going to copy our numcon.cpp to numcon2.cpp. And this time, we'll use our cstdio library, and we're going to use the cstdlib library to get A to I and A to F, which are going to be ASCII to integer and ASCII to float. So these will be the ones that use character arrays. So let's create couple of character arrays here. Create a couple of character arrays. I better define my size. And so I'm just going to use string copy to get some. Oops. There we go. We'll copy the string 97 into the first array, and we'll copy the string 1.234 into the second array, or the text 1.234 into the second array. And so this time, we'll use A to I and A to F to do our conversions. And I guess I better use my printfs to display this stuff now. So we'll put in S1 is equal to our I. So the contents of S1 will get substituted for that %s. The contents of I will get substituted for the %d. And then we'll do the same sort of thing with S2 and F. And we'll try it again with garbage in just a second. So, assuming I haven't messed up my syntax anywhere in here, I've got my two arrays. I'm initializing them with text versions of 97 and 1.234. I'm going through and doing the conversions, and then I'm printing out the original text strings and the converted values. So let's see if this actually compiles. numc2.cpp-o numc2. Oops, I forgot to include my C-string library. And so we'll try compiling again. That looks a little better. And sure enough, we get the 97 comes out at integer 97, and the string 1.234 comes out as the float 1.234. And so now, let's try it again using some garbage values. So let's copy garbage into S1, and we'll do the two conversions from the garbage version and see what we get coming out. Oops. Guess I don't need to redeclare my variables, do I? And so this time, we see that the a to I and a to f, if you give it garbage data, it returns a value of 0. So when you're playing with a to I and a to f to convert things from character arrays into ints and floats, you do have to be aware that if it gets bad data, it's going to give you back 0 as the result. So those are things to watch out for. All right, so let's have a little bit of play with some of our options. So I mentioned that the cstdio library gives us sprintf and scanf to read things from character arrays and write things into character arrays. So let's say we take our character array, so I'm just text here, and I've got some integer 3, and so I want to write the value of x into the array, but of course it's got to get stored in there as text, as characters. So what I'm actually going to do is write an entire blob of text here. So what I want to go into the array is ultimately x is 3. And so here I've got my regular kind of printf syntax for x is %d and whatever the value of x is, right? So if this was just a regular printf, it would display x is 3 on the screen. But with sprintf, we can say, oh, well, don't put it on the screen, put it in the array. So this will actually put x is 3 and then a null terminator into the character array. And there's another version of this, snprintf, that just gives you a safeguard so you don't run off the end of the array, so it lets you specify a maximum size. So I can specify my array and the maximum size, and then the string to write and any arguments that get plugged into the string. So we can write into a string. And then the flip side, scanf, allows you to read from a character array instead of reading from the keyboard, instead of reading from standard input. So in this case, you give it the character array or the text that you're reading from. So I could put text here, and I could put my text variable as that first parameter, and then the format string for whatever kind of thing you're trying to read out. So if I'm hoping that an integer is the first thing, then I might say, okay, read an integer from that string and put it in this variable. So this part looks just like our regular scanfs, right? Read something of this type into this particular variable. It's just that in the beginning, we specify here's the character array, or here's the text string to read from. And again, that one's done with scanf. So now we can essentially write formatted information into a character array anytime we want, and we can read information from a character array into other variables anytime we want. And then for the IOStream side of things, the cin and cout side of things, there's an sstream library that gives us similar functionality. So if we want to read from the contents of a string, what we'll do is create a special input stream that we can read from, and we're going to build this from the text string. So let's say I've got a string and it's got, something in it. It's got 905th Street in there. So what I'm going to do is build a readable stream from that. So this is type iString stream. So that data type is created in the sstream library. So if you've got sstream hash included, you can use this data type. And here I'm just creating a variable to name my stream. I'm just calling it strm. And we're saying build this input stream using whatever data is in text. So this thing is now a readable stream that has 905th Street inside it. And then I can use that stream the same way I would use cin. So I can say things like the stream, greater than x. So it's going to read from that stream, from the 905th Street, into x. So hopefully in this case it's going to read the 900 into x. So if you've got a text string and you want to read pieces of that into other variables, then you build one of these streams from it and then use the stream the same way you would use cin. Now, similarly, you can use get. Oh, this is going to have the same issue as the syntax in our earlier video, where this should actually probably be our stream.getLine to go through and get the content from our stream into our variable, and we just specify the delimiter to use at the end. But we can go through and read from, indirectly reading from our strings, right? We're creating an input stream we can read from based on a given string. And then we can also go the other way around. So the iString stream was to read from, the oString stream is to write to. So let's say I've got an integer variable x, and I want to write something like x is, and whatever the value of x is, into a string variable. I'm going to do it in two steps. I'm going to create an output stream, so an oString stream. So this is going to be something that I can write to. And again, I can give it any name that I want. And then I'll write the content into that. So my stream, and so I'm using this just like cout, right? The less than x is, less than x, then an endl, and it'll write this content into that stream, and then I can set my string variable from the content of the string. So it's whatever your variable name is, dot, and then this str method. And so again, we can convert the other way around as well. So we can now play with reading and writing to and from strings, or reading and writing to and from character arrays. And it gives us a little bit more flexibility in terms of creating some data and then putting it wherever we want, or extracting data from anything else that we happen to have created. And again, we mentioned this in an earlier video. I just wanted to rehash it now. If you're converting back and forth between a string, the actual class, and a character array, remember that the string is a more complex data type. You can assign from a character array to a string, but not the other way around. Right? If I've got data in a character array and I want to put it in a string, the string class is smart enough to allow me to use this operator and say, okay, well, here, assign whatever's in this to s, and it'll copy it all across. But you can't go the other way around. You can't say text equals s. So we would have to use something like string copy to say, okay, copy the content of the string into my character array. Right? So remember, this expected to get string copy expected to get two character arrays. So the first one is the one we're copying into, and the second one is the one we're copying from. But again, remember that this second thing has to be a character array, and strings are more complex than that. So if I just want to get the character array portion out of a string, we use this special method, the c_string, c_str, to say, okay, just grab me the character array portion of that for the moment, and I'm going to use that to copy into my text array. So those were the key things that I wanted to mention. And again, we're just going to keep playing with all of these different methods and all of the different functionality over pretty much the rest of the semester. All right, I will leave it there for now, and we'll play more next time.